Okay, pre-AP, good morning. I don't know when y'all are gonna watch this, but it's morning for me, so good morning. So I'm gonna talk to you about stoichiometry. And so first of all, stoichiometry is just the study of the amounts of substance and chemical reactions. So just like whenever you cook or something, you need certain amounts and you produce certain amounts. So if I, want 24 cookies, I need to have 2 1/4 cup of flour. I need to have so much sugar, so much butter to make that many cookies. And if I want to make more cookies, I need to add more to my recipe. Same concept. And so we're looking at all these chemical reactions and saying, if I mix this much of this chemical with this much of this chemical, how much product am I going to produce? Or if I know how much product I have, it's like, well, how much did we have to mix to get there? And it's really important in chemistry, and it's heavy in math, but it's okay because we have this little trick, the heart chart. And so I'm going to show it again in just a second. But that being said, so in stoichiometry, you're going to be given a given. Your given is either going to be in grams, atoms, molecules, particles, ions, liters, or moles. Depending on what it is, depends on where you start on your heart chart. So here's our heart chart, okay? So moles is at the center, okay? If I'm given grams, I'm going to start here. I use molar mass to get to moles. We always want to get to moles. If I'm given atoms, molecules, ions, particles, Avogadro's number to get to moles. If I'm given liters of a gas, I use molar volume to get to moles. If I'm given liters in a liquid, I'll use molarity to get to moles. If my given is moles, I start at my heart because I'm already in moles, so I can skip this side if my given is in moles. So I'll say that one more time. If my given's in moles, I can just start at the heart, okay? Then whatever it's asking us for is where we stop. If it asks us for moles, we stop at the heart, okay? So we may need to switch compounds, but we don't need to keep going past. If it asks us for grams, then we go and use molar mass to get to grams. If it asks us for Avogadro's number, or atoms, molecules, particles, ions, we use Avogadro's number. If it asks us for liters of a gas, then we use molar volume. And then if it asks for liters of a liquid, we use molarity. And so you just follow along with the chart where you start and where you're given. What you're given is where you start. What you're looking for is where you're going to end, and you just follow the chart. Now then, you still need to be able to set up units to cancel. So remember, when we're working these problems, we always start with our given. So we work, and we always start with our given. And then we always set up units to cancel. And so if I have grams on top, then I need grams on bottom. And you need to make sure that you use your conversion factors and you keep them the same. But that's how we work stoichiometry. I think the hardest parts of this are going to be the new stuff. So you should be familiar with how to work with molar mass and how to work with Avogadro's number. So the new ones are going to be molarity and molar volume. Molar volume is just like everything else we've been doing. Molar volume is just a constant. And so if we're at STP, which every problem I give you will be at STP, it's going to always be 22.4 liters is equal to 1 mole, okay? Just like Avogadro's number is 6.02 times 10 to the 23rd, and then atoms, molecules, particles, whatever is equal to 1 mole. Okay, and so it's equal to 1 mole, so you'll use it the same way we use molar mass and Avogadro's number. So that one's pretty simple. Molarity is the one that's different. And so molarity is about concentration of a substance. And you probably already know this a little bit, you just don't realize you do. If you have something like Gatorade, they used to do this all the time to us in athletics and we hated it. But like Gatorade, if it's really strong, you can take some of it and pour it out and then pour some water in it and dilute it and make it not as strong. They used to dilute our Gatorade not because it was too strong, but because I think they were cheap and they didn't want to give us a lot of Gatorade. But for athletics, and so we would have this watered down Gatorade, diluted Gatorade, but it changed the concentration. And so your concentration is how much of the stuff you have per volume. And so normal Gatorade's pretty concentrated. You have a lot of sugar, a lot of the electrolytes, a lot of that stuff all in a small little container. So if I took one Gatorade bottle and I poured it out into a gallon bucket and then I filled the rest of it up with water, it would not taste the same because there wouldn't be as much Gatorade in the solution, in that makeup. And so it's kind of like the concept of molarity. In fact, that is a molar problem. But that being said, molarity is represented by a big M, which is equal to moles per liter. So if I had a 5 molar solution, that means I have 5 moles in every single liter that I have. Do I have to have a liter of the substance? No, in fact, in chemistry, a liter is huge, and we don't typically use a liter. We typically use much less than a liter. And so because of that, you need to be able to convert. So if I had 25 milliliters of this substance, or actually we'll start with something easier. We'll do 100 milliliters of this substance, okay? Then that's actually equal to, well, 1 liter is equal to 1,000 milliliters. So to figure out how many liters that is, because I need to convert, I'm going to multiply by the conversion factor, which is just like dividing. I'm making sure I'm still on the screen. And so milliliters cancel milliliters, and so you're left with liters, okay? So that's like saying I have 0.1 liters. And so then if I have 100 milliliters of this substance, I just take 5 times 0.1 liters, and that gives me 0.05, and that would be moles. How does that work out? Well, if we look at our units, right here, I have 5 moles per liter. If I multiply it by 0.1 liter, the liters cancel liters, and that just gives me moles. And so, again, we always want to get to moles, the heart, as fast as we can. And so for molarity, this is what you're going to have to do. So hopefully it's a little helpful. I'll make more videos when I'm less tired and maybe just focus on molarity only. But that's a little bit of a breakdown of Stoich. I'll do some example problems on here too, okay?